Hey students, while solving problems on engineering mechanics, frequently you will have to add forces. Now, force is a vector quantity, you all know. So when you want to add number of forces, we don't just consider magnitude, we'll have to consider direction. So how we add forces analytically? So simple, we resolve each and every force involved in the system in two components which are perpendicular to each other. The components of two forces which are perpendicular to each other are called rectangular components. Generally, we resolve forces along x-axis and along y-axis. So to add forces, we add all components along x-axis, we add all components along y-axis so that we get the two components of the resultant. But before we proceed for resultant, what is very important is to have enough practice of resolving forces along x-axis and y-axis. So in this video, we are simply going to have practice of resolving forces along x-axis and y-axis. So let's begin. Resolution of a force into rectangular components. So here is force F. It has magnitude F. It is rightwards upwards and it makes angle theta with x-axis. You know three parameters associated with a force: magnitude, direction, that is represented by angle made by the force vector with a reference line, and the point of application. I have labeled point of application as point O. Here I have constructed a rectangle, and along the two sides of the rectangle through point O, I am showing two forces. Now, by law of parallelogram of forces, we can say that force F is resultant of these two forces along x-axis and along y-axis respectively. So, these two forces are components of force F, or we can say that the force F is resultant of these two forces. Now, if magnitude of force F and its angle with x-axis theta we know, then what are the magnitudes of these two components? Now, at school level you have studied law of parallelogram of forces. You must be knowing that is length of side of the parallelogram is directly proportional to magnitude of the corresponding force. So in this case, magnitude of the horizontal component is length of this side, and by geometry of right angle triangle, we say that this length is F cos theta, nothing but magnitude of the horizontal force, and vertical length of this rectangle, nothing but vertical side, length of vertical side of this right angle triangle. Since it is opposite to angle theta, we say F sin theta, nothing but magnitude of this vertical component. So F cos theta and F sin theta are two components of the force F. F cos theta is component along x-axis and F sin theta is component along y-axis, where theta is angle made by the force vector with x-axis. That is, if angle of force with x-axis is mentioned in the diagram, then component along x-axis is cos component. Now here in this diagram, two systems of forces which are equivalent to each other are superimposed. Which are the two systems? A system of this single force at an angle theta and a system of the two forces which are perpendicular to each other. Magnitude of the two forces, force along x-axis F cos theta and force along y-axis F sin theta. So these two forces are component of this single force F, means these two forces are equivalent to this single force. So these two systems are equivalent systems. Now it is the same force in this diagram, force F. It is rightwards upwards, and that makes angle theta with x-axis. Now in this next diagram, check. It is the same force acting at point O, magnitude is F, but in this diagram we have inserted angle of the force with y-axis. X and y-axis are reference axis. So to define direction of a force, we may use angle of the force with y-axis, no problem at all. But if you are using angle of force with y-axis, then remember, component of force along y-axis is cos component. So in this diagram, vertical component or component along y-axis is F cos phi, and component of force along x-axis is therefore F sin phi. So remember, adjacent to the angle component is cos component. What is very important, that is, to solve problems in engineering mechanics, you must be very fast in identifying these components in magnitude and also in direction. Now here in this diagram, I have shown 4 forces. All 4 forces are well defined. What do you mean by that? 3 parameters are associated with the force: magnitude, direction and point of application. So in this diagram, magnitude of force is 35 Newton. Its direction is rightwards upwards 40 degrees with horizontal or 40 degrees with x-axis. And acting at point A, that has coordinates 7, 4. Let's assume that all distances are in meters. So these coordinates are in meter. So this force similarly, it is leftwards upwards. That makes angle 60 degrees with vertical or with y-axis. Now, while solving problems, you must be able to visualize components of the force. Visualize. It's not necessary to draw the components in the diagram. Visualize the components in the diagram. And it's very simple. Focus on this arrowhead. That suggests you that this force is rightwards upwards and the force is acting at point A. So components are acting at point A. Simple. In this diagram, the force is, check, leftwards upwards. So components are leftwards upwards and the force is acting at point B. So components are at B. So this is how visualize the components. Don't actually draw the components. For example, here it is 50 Newton force. I can visualize the component. Without drawing the components, I can see the components here. You must be able to see the components here. Simple. Check here, this force is leftwards downwards. So components are leftwards downwards and this force is acting at point C. So components are at point C. So at point C, leftwards downward force. Right now I am drawing these components in the diagram, but finally while solving problems on statics or while solving problems on statics, you must be able to visualize these components. This is 25 Newton force. It is rightwards downwards. So components are rightwards downwards and this force is acting at point D. So components are at point D. Simple. What about magnitude of these forces? So adjacent to the angle component is cos component. So in this diagram, for this 35 Newton force, we have inserted angle with x-axis. So x component is cos component and therefore y component is sin component. Also take care of unit, it's Newton. Now in this case, we are using angle with y-axis. So remember, adjacent to the angle component is cos component. So vertical component is cos component. So horizontal component is sin component. In this case, that is the 50 Newton force, we have shown angle with x-axis. So x component is cos of that angle and y component is sin of that angle. Similarly, in this case, we have shown angle of that force with x-axis. So adjacent to the angle means component along x-axis is cos component and vertical component is sin component. So check here, this 60 degrees angle is with y-axis. So y component is cos component. If there are 10 forces acting on a body, or if there are 10 forces you have shown in a diagram, then it's not necessary to show x and y components of each and every of those 10 forces. It will be 20 more vectors in the same diagram. So that diagram, instead of helping you to solve problem, that diagram is going to confuse you. So Develop habit of visualizing component of forces instead of showing those components in the diagram. And it's very simple. If force is acting at point A, components are acting at point A. If force is rightwards upwards, then components are rightwards and upwards. But if you are showing angle with x-axis, then x component is cos component. And if you are showing angle of that force with y-axis, then y component is cos of that angle. So it's simple. But let's have practice. Now if you want to add all these forces, what should be your approach? How we add forces? We add x component and then we add y components. When you want to add horizontal components of forces, you must be able to focus only on horizontal direction of these forces without any confusion. For example, this force 35 Newton, focus on the arrowhead and you know that it is rightwards upwards. But while adding x components, just check whether force is rightward or leftward. So this force is rightwards. This force is leftwards. Now, to practice it, one by one, you tell me horizontal direction of all these forces. What is horizontal direction of this force? Just focus on the arrowhead and it's rightwards. So horizontal component rightwards. This force has horizontal direction leftwards. This force has horizontal direction rightwards. This force has horizontal direction leftwards. Check here. When imagine that you are moving in this direction. Are you moving on the left side of the screen? Yes. So its horizontal direction is leftwards. Actual direction of the force is combination of leftwards and downwards. But while adding x components, you will be interested only in horizontal direction. So this force is leftwards. What about this 53 Newton force? Is it moving on the left side? Yes. So focus on arrowhead. So it is leftwards. And when you visualize the components, visualize at the point of application of the original force. So this force is acting at O, so components are acting at O. That is the logic. This force is rightwards. And this force is neither rightwards nor leftwards. This 15 Newton force is neither rightwards nor leftwards. And you must be very fast in identifying direction. That should not be your problem. So the force is rightwards. This force is leftwards. This force is rightwards. 50 Newton force is leftwards. 53 Newton force is leftwards. 25 Newton force is rightwards. And 15 Newton force is neither rightwards nor leftwards. Similarly, when you want to add y components, vertical component of all forces or component of all forces along y-axis, just focus on vertical direction of forces. Just check whether the force has direction upwards or downwards. Here, 35 Newton force is upwards. This 40 Newton force is upwards. This 45 Newton force is downwards. This 50 Newton force is downwards. Downwards doesn't mean below x-axis. Downward means its direction is downwards. This 53 Newton force is upwards. This 25 Newton force is downwards. This 15 Newton force is downwards. And now let's add the forces. And how we add forces? We add x components of all forces, we add y components of all forces. Now while writing that expression sigma fx means while adding horizontal components of all forces, consider each and every force, check whether it is rightwards or leftwards. If it is rightwards, use positive sign. If it is leftwards, use negative sign. In the diagram, if angle of force with x-axis is mentioned, then write x component as cos. And if angle of force with y-axis is mentioned, then write x component as sine of that angle. So here it is summation fx, means sum of x components of all these forces we are going to add. So this first force, 35 Newton force, is rightwards. And we are using angle with x-axis, 40 degrees. So 35 cos 40 positive. Why positive sign? Because it is rightwards. And why cos of 40? Because we are using angle with x-axis. So x component must be cos component. Now 40 Newton force is leftwards. So it should be negative. We have shown angle of 40 Newton force with y-axis. So we should write x component as sine of that angle. So minus 40 sine 50. This 45 Newton force is rightwards, so positive. We are using angle with x-axis, so x component is cos. 50 Newton force, check here, it is, of course it's moving downwards, but simultaneously it is moving leftwards. And while writing x components, we are interested in only horizontal direction. So it is leftwards, that's why we should mention here negative sign. And we are using angle with x-axis. So we should write x component as cos of that angle. So minus 50 cos 65. Now 53 Newton force. Again, it is upwards, that's true. But right now we are not interested in its vertical direction. We are writing horizontal components or x components of all these forces. It is combined direction, leftwards and upwards, but focus on the horizontal direction. And it is leftwards, so it should be negative sign used here. But we are using angle with y-axis, and here we are going to write x component, so we should write sine of that angle. So minus 53 sine 25. This 25 Newton force makes angle 30 degrees with x-axis, so 25 cos 30. Because angle is with x-axis, x component is cos, and the force is rightwards. So x component is positive. And 15 Newton force is neither rightwards nor leftwards. So in resolution of this 15 Newton force along x-axis and along y-axis, its x component is 0. Have you realized? It's very simple. Similarly, when you want to write y components, listen, focus only on whether the force is upwards or downwards. If it is upwards, positive. If it is downwards, negative. And if we are using angle of the force with y-axis, then y component cos. Otherwise, y component you should write sine. Let's have practice. So here I am writing y component, sigma Fy. 35 Newton force is upwards, that's why positive, and we are using angle with x-axis, so y component should be sine 40. 35 sine 40. 40 Newton force is also upwards, so positive. But here we are using angle with y-axis, so y component should be cos 50 degrees. So 40 cos 50 positive. 45 Newton force is downwards. Remember, do not get confused with its rightward direction. What is combined direction of 45 Newton force? Rightwards, upwards. But right now we are using vertical components only. So consider only its vertical direction, and it is downwards, so negative. And we are using angle with x-axis, so y component you should write sine of that angle. So minus 45 sine 30. 50 Newton force is downwards, and we are using angle with x-axis, so y component you should write sine of that angle. 53 Newton, we are using angle with y-axis, so y component we are writing here, so it should be cos of that angle, and the force is upwards. So positive 53 cos 25. This 25 Newton force is downwards, so negative. And we are using angle with x-axis. So y component you should write sine, minus 25 sine 30. And this force is along y-axis itself. So, and it is downwards, that's why it is minus 15. So it's that simple. Purpose of this video was to give you practice of adding x components of all forces, sigma fx, and adding y components of all forces, sigma fy. Hope that you have understood it properly. If yes, like the video and share it with your friends. Don't forget to subscribe my channel and in the comments write "give me more." That will encourage me to upload many more such videos, and certainly all those videos will clear your concepts and you will be very fast in solving problems on statics and dynamics. Thank you.